Prove that the sum from I equals 1 to n of 1 over 3i minus 1 times 3i plus 2 equals n over 6n plus 4 for all integer or positive integer n. Right, so I'm going to write out our conjecture in a kind of, as a series of terms. It's going to take a bit of space, but I won't write many. But firstly, I'm going to write the thing we're actually trying to prove, the proposition. So proposition we're trying to prove, Pn is, that I guess it would be 1 over 3 times 1 minus 1. 3 times 1 plus 2, so that would be when n equaled 1, plus 1 over, and then it would be 3 times 2 minus 1, 3 times 2 plus 2, so that would be when n is 2, plus, and then I'm not going to do many, I'm just going to go up to the last one when it is n, so plus 1 over 3n minus 1, 3n plus 2, 3n plus 2, so that's kind of the series in shortened form, and the conjecture is that all of those things added together equal n over 6n plus 4 for all positive integer n. Okay, that's the conjecture, and we're going to attempt to prove it. So the proof, and we're doing it by the principle of mathematical induction. Induction. Right, so we start with our base case. We're showing that this is true for all positive integer n, so the lowest positive integer n is 1. So let's see what happens if n equals 1. If n equals 1, so we need to show that the left hand side equals the right hand side. So the left hand side is 1 over 3 times 1 minus 1. 1 over 3 times 1 minus 1, 3 times 1 plus 2, so that's the left hand side. Is that equal to the right hand side, which would be this with n being 1, so 1 over 6 times 1 plus 4. So this is 1 over, well, 3 times 1 is 3, minus 1 is 2, 1 over 2 times 3 times 1 is still 3 times 5. Does 1 over 5 equal, and this is 6 plus 4, 1 over 10. Well, it does, yes. 1 over 10 does equal 1 over 10. So that shows us that P1 is true. So that's a good start. Right. So what I'm going to do, because I'm going to have to use a bit of room here, and then let's try and get a target in mind. And remember, the second stage is to assume that the kth case is true. So if proposition K is true, if it is true, then that would mean that this expression here, but with a K, so 1 over 3 times 1 minus 1, 3 times 1 plus 2, plus 1 over 3 times 2 minus 1, 3 times 2 plus 2, so that's when n equals 1, 2, plus dot dot dot, 5 dots, all the way up to 1 over 3k minus 1, 3k plus 2. So if pk is true, all of that must equal to k over 6k plus 4. Right, I might actually just think about our target. I'll write it here. So our target, when we get an expression for pk plus 1, remember we always want to know what we're aiming at, and then we can do the algebra to try and get there. So the target is going to be this, but wherever you see an A and you see it, it's k plus 1. So the target is going to be k plus 1 over 6 k plus 1 plus 4. That is what we're going to be looking to show. Remember, we assume that this is true, and then we show that the k plus 1th case is true whenever this is true. So pk plus 1, so we kind of write it in terms of the left-hand side, then we use our assumed bit to simplify it, and then we wrestle it into the target. That's always the strategy, always, for series. So pk plus 1 is going to, remember, we start from the start, so it's 1 over 3 times 1 minus 1, 3 times 1 plus 2, plus 1 over 3 times 2 minus 1, 3 times 2 plus 2, so that's the first two terms, plus dot dot dot, plus, and then we better put the kth case in there, which is 1 over 3k minus 1, 3k plus 2, and now plus the k plus 1th case, which is 1 over 3 k plus 1 minus 1, and then 3k plus 1 plus 2. Plus 2. So that is the k plus 1th case, right? So we know that everything up until the last term, we can use our result when we assume that the kth case was true and say all of that equals k over 6k plus 4. So that's all of that, and then it's just plus what is new term, 1 over. And then I think I might just sort these brackets out because we're going to have quite a bit of work to do on that. So let's see where we can go. So that would be 3k plus 3 minus 1, so that would be 3k plus 2. And this one would be 3k plus 3 plus 2, so that would be 3k plus 5, right? So that's the k plus 1th case, or pk plus 1. And I think a reminder of our target would be quite good, seeing as it's on the other slide. What we're trying to turn this whole term into is k plus 1 over 6 k plus 1 plus 4. That is where we want to end up at. So right now we don't have that, so we're going to have to do some work because we don't have a k plus 1 on the top or on the bottom. So how are we going to add these things? Well, if you look at this 6k plus 4, you can already say, well, that is 3 times 3k plus 2, so you can see we can get towards a common denominator, which is quite handy. So that equals k over 2 times 3k plus 2 plus 1 over 3k plus 2, 3k plus 5, right? So now if we want to add these two things with the lowest common denominator, well, we've got a 3k plus 2, and then we also need a 2 and a 3k plus 5. So what we're going to do, we're going to get this fraction here, and we're going to times that by 3k plus 5 over 3k plus 5, so to this one. And we're going to get this one, and we're going to times it by 2 over 2. And then we've got a common denominator of 2, 3k plus 2, 3k plus 5. Right, so that would be equals k 3k plus 5 plus 2, just plus 2 over, well here you've got 2, 3k plus 2 and 3k plus 5. Right, so if we work on the top here, I'm going to leave this in a factorized form and hopefully something good will happen with it. I'm just working on the top. This is going to be equals 3k squared plus 5k plus 2, which we will try and factorize. So then we've just got the bottom bit, which we're not going to touch yet, over 2, 3k plus 2, 3k plus 5, right? So now we're looking to factorize 3k squared plus 5 squared, plus 5k plus 2. 3k squared plus 5k plus 2 was quite nice prime numbers at both at the start and the end. So hopefully that's going to be 3k and k, and there's going to be a 2 and 1 somewhere. So if you have the 1 here, well 1 times 3 is 3 and then 2 times 1 is 2. So you're going to have the 1 here and the 2 here. It's all positive. And that is quite friendly, because now if we turn this into that, then we're going to get to remove that factor. But I'm going to have to change. Okay, so now in the numerator we have 3k plus 2 over k plus 1. And in the denominator, we still have this factorized form of 2, 3k plus 2, 3k plus 5. And I'm going to write down the target again, because it's really, really important to always know exactly what you are aiming at. So don't forget, we're target is k plus 1 over 6, k plus 1 plus 4. And hopefully, once we knock these two off, so we can cancel these two, 1, 1. We've suddenly opened it up and we're looking like we're going to get 2 linear factors. So equals, on the top we've got our k plus 1, so we're definitely looking, looks like we're going in the right direction, over, well this is 2 times 3k plus 5, so that is, I'm going to expand that, 6k plus 10. So all we've got to do, can we turn 6k plus 10 into 6k plus 1 plus 4. Well, this is 6k plus 6 plus 4, which is 6k plus 10. So equals k plus 1 over 6k plus 1 plus 4 as required. So now that shows us, since P1 is true and k plus 1 is true whenever pk is true, right? Pn is true for all positive integer n. Pn is true for all positive integer n. For all positive integer n. And that is because of the principle of mathematical induction. Okay, so quite a tricky one. The concept wasn't any different to what other series ones that we've done, but it's just the level of the algebra really. But if you know what your target is, if you know you're looking for one fraction and you've got a sum of 2 fractions, firstly you know you've got to add them, you need a common denominator. Then if you know you're looking for, say, if you're looking to reduce the number of factors, you know you're going to look to cancel some kind of linear factors off. So you build towards that. Always make sure you know exactly what you're aiming at, and do not forget to write the proof properly at the start, saying what you want to prove, how you're going to prove it, doing the base case, then assuming the case is true, and so on. And make sure you finish the proof properly. And it's generally worth 6 marks, the whole thing.